I just shared the link on Facebook. I thought that if I added you on my chat, then maybe you can talk to. Wait, so you want me to Skype and we can use your Skype and then now you're making us here on What? Yeah. Well, now you can look at my stuff, I guess. Oh, sorry. I guess I got this one.
So we are going to get started in about 5 or 10 minutes. Please feel perfectly comfortable coming in and sitting down. The kids had a week to get the design ready to present to you guys. So they are moving things onto their poster boards as we speak. But I think they all have really good ideas. So 5 or so more minutes, and then we'll go ahead and get started. Please come and sit. We're full of chairs or something. Feel comfortable, let's get going.
What happened? There's only one watching. I thought that was one. It could be. I don't know. That's an
That was so funny. Oh, I don't know. I can't find my pants. Why can't I find them for me?
Yeah, they have a whole competition for like stop by. At least once. Oh, where's that? But that was right here, isn't it? I think the whole, it's the big district. The big district. I don't know. I was trying to find out today. I meant to ask Black, but he came in to tell me something. You know,
If you guys hadn't noticed, there is a new theme to this year's game. Oddly, they don't usually have themes this specific, but it's exciting. So, just so that you guys know, as a little heads up, the teams hit fun. Okay, so welcome you guys. I really hope you guys have fun today. Thank you all for coming. We have a couple people that are going to talk to you guys about some other things like the school district and what we're doing first, and some partnerships that we're forming with our we off the scene for the robots? So, well, first of all, I wanted to say thank you to all of you for being here tonight. This is really a fun process. You haven't been through this. I've been to a number of these, and it's really exciting to have the community be a part of not only helping to shape my robot project, but really give our students real life experiences of pitching a project, pitching their ideas to a client. And I think that's really that's exciting. I wanted to say a little bit about why I believe robotics is an important part of our program here in our school, and something that's grown over the last few years. Robotics is unique in terms of STEM. And here people talk about science, technology, engineering, and math. And robotics is one of those fields that really brings all of those things together in a powerful, hands-on way, unlike any other field you can look at. You've got programming as part of this. You've got engineering. You've got design. You've got all kinds of things related to electronics and robotic motors and all these types of things coming together. And what's powerful about it in terms of a learning experience for our students, because we do this with second graders now, from the clubs and activities, we do with seniors, is that it allows students to really have ownership over problem-solving things on their own. If a robot doesn't do what you wanted it to do, it gives you immediate feedback. So you can go back and figure out, is it the code? Is it something mechanical? Is it something in the design? That's a unique thing in terms of helping students learn on their own and develop their own ideas. And these students tonight, this is stuff that they really truly develop on their own. They're going to have the opportunity to work on these robots and put it together. But more than that, for our school, what I've been really excited about, of course, is this particular program has been the community involvement and their investment in a K-12 vision for K-12 education in robotics. Our local school levy is something that has invested dollars from our community. Our community has supported that investment, dollars into this program. And this program has grown from a high school-based class to middle school. We have robotics, middle school robotics programs at each of our middle schools, during school day. And then we have clubs at all levels. We started all the way at the elementary school level, coming from 3 to 9, at the elementary and including one kindergarten team. That's something that was not happening just 5 years ago. And so that's thanks to the support and the investment of our community. I think that is tremendously exciting the way to provide those opportunities for our students all the way across the spectrum. And really, more than the investment of our community, more than the community support, it takes individuals to help have the vision and the passion and the dedication to make that possible. And that really is epitomized by the tremendous work that I'm so thankful for him, Mr. Doga. I would like to give him a round of applause. Give a lot of credit to people in this room and a lot of people in this room who have been tremendous support for him. But he's truly the driving force. He's the one that is always there. He's the one that continues to want to see students be successful, and he wants to see this be a district-wide and maybe even kind of growing out into an island-wide program. And it's thanks to his leadership that we're able to do what's possible back today. So I'm thankful for him. I'm thankful for your support and your investment. And this is going to be an exciting evening, an exciting season for our students. And I think you're in for a wonderful treat. So thank you very much.
So we actually have Mark on. He is from IDEX, Department of IDEX, and he wanted to say a few words. I'm Mark on manufacturing. I just want to be manufacturing. Issues and that's We're going to
the officers scientific and approved by IDEX. So the IDEX Corporation is the IDEX Foundation that ensures that we IDEX Foundation was established in 2014 with a mission to positively impact the community, which IDEX people really work. Specific focus area of our STEM education and also one of the things about the robotics here is that they really mind a lot of leadership development and they have to spend their time learning about engineering technology and also their commitments to community service projects building community with site projects. So on behalf of the IDEX Foundation, I'd like to check $10,000.
Lines up to kind of talk to you guys. We have this young lady, she is the president of our booster club, and
first of all, when you think about a booster club, you usually think about sports. And the thing that we always talk about here is with robotics. These students put in between 50 and 35 hours a week during those seasons. And they go to school. So we really think about this as a sport of mind. We are a booster club. There are several of us, but the key people who really help make it come. Which is fun. Well, Stronghold, Wanda is, and Laura Colton. We're also community members, but really what our job is as boosters is to get as much out of the way as possible so that these students can build robots. So we raise money, we feed them a lot. We try to get them to the competitions all the time. We do as much as we can to help them promote STEM within our community. We've really done a lot of work with elementary schools and helping these students go out and mentor the younger groups, and we're trying to move the work from the ground up. So if you're interested in getting involved at all, as a involved in that system, you can come see one of us. If you want to be involved as a mentor, sometimes people think, oh, mentor, oh my gosh, I can't do that. I'm not anything about robotics. We have so many different things that you can do as a mentor. We need people who can write. They have to write essays. We need people who can build. They have to be study carpentry, put together mock-ups. We need people who can do leveling. We need people who can be classroom language. And there's a job for anyone. So if you have a few hours, you're interested at all, please come to one of us. We need to times a month, and we could not do any of this without the support of companies like IDEX, Boeing, OSPI, our own Career Tech, and the Lions Club. All of those groups contribute hugely. So I want to thank you. United Tech Corporation is supported if we want to make small contributions, we're happy to do it. Just recommend that between 25 and 30% of our students in this team have some kind of scholarship to do it. We would like to see that grow. We'd like to contribute that. We come to others. We talk to research and
okay, so thank you guys all for coming. And this year, we wanted to say thank you. We have had some major accomplishments this year. And so the first accomplishment that I'd like to thank you guys is the district chairman's award, which the chairman's award celebrates teams who have done and support the community.
ask is if we ask a random person in your high school if you guys had a robotics meeting, would they say yes? I think we should be good if we say that. So we need to say thank you, you guys, you guys supporting us is what made that award possible. Second of all, Michael Edward was recognized as one of the top 10 students embodying what FIRST Robotics is all about in the entire world. So not in the state, not in the country, but in the world. So he's here today. We can talk to you guys a little bit. But he is going on to great things. He's already been accepted and has applications out to MIT and he's going to go into something else. Had a funny thing happen. We were talking to, I was talking to the president of WPI, and I wanted to call Michael over. And we're like, Michael, come here. It's like, I'm busy. I'm like, Michael, come here. Because it was the president of a really cool college. And finally, he comes over and goes, what are you doing? It's so important. He's like, I was talking to the president again. So, okay. We deployed successfully 2 prosthetic limbs that are out in the world used by children from elbow down. So there are 2 children who have arms, but didn't have arms in the year because of the work this team has done. And we did do that for the community. The 3 printers that we used to build these prosthetic limbs were paid for using an OAGF grant. So OAGF is the Harbor Education Foundation for fun. Foundation, and they raise money every year for programs like ours, and they raise money for that. So thank you very much, and thank you to INEX, because they just get one of our projects. And we've expanded opportunity. We are now a K-12 program and beyond. As soon as you come back, as among us, you mentor the team. We have mentors that they're as old as me. So the point is that we have expanded opportunities for children. If you have young ones, we want them. That sounds weird. Please, if you have young ones, we want to get them into the program early so that, 8 years from now, we have an amazing team, which we already have, but we want to make it even more amazing. So thank you all. Next up, we're going to Michael come and talk to you guys about failure, because we better talk to you about failure. good at anything, that's not wrong. But you want their robot design to be good at something. So when you talk to them, especially when we do question and answer session, is your robot good at something? Right? Whatever that something is, does it earn points? Is it good at the right things? So this is the game element. In years previous, the kids have built robots that keep the game elements outside the robot, kind of like an arm loop that holds it. The problem is that you have this thing that's vulnerable sticking up in front of your robot. Another robot's drive up and smash it, and then you're done. So we are focused on the internal control of all the game elements. So we want to take game elements outside the robot and have it inside, just like a football player is running down the field. You want that ball constantly nice and tight. It doesn't run the ball out here. Let it back. So the internal control of game elements. You guys are going to watch the game animation, but it shows you what the game is. Do the kids have a good strategy for playing the game? And they don't look this into. All three teams are using something that I promise you is going to be difficult for us to get hold of. You guys will see what it is in a minute. And then the last thing is we need to hold them to a high standard, not too high, but we do want to bring the best out of these kids. So do not let them undersell it. If the kids say, we think we can build this in 2 weeks, it's going to be really easy, maybe that's not what we want to do. We want to push them a little bit harder than that. Okay? So we want them to live up to our expectations. We want to challenge them. We want to make sure they keep the ball inside somehow. And we want to make sure that they are good at something. All right, so this year's game is called Stronghold, and here is the game animation.
Welcome to the FIRST Robotics Competition and the 2016 Current Challenge FIRST Stronghold. The Alliance quest is to bridge the opponent's defenses, known as the outer works, within their tower with boulders and capture. The low bar in position 1 is the opponent. The defense in position 3 takes the output by all expansion. Opponents are savvy and will use the cage to select the remaining 3 defenses. Strengthen their outer works well in line for the next match. There are more than 10,000 possible field configurations. Robots start in the neutral zone and may have 1 boulder each. Additional boulders will be placed on the midline and in each castle. Alliances may assign a spy bot to start in your opponent's courtyard, and a human player to occupy a spy station. Signal intelligence about activity. Seconds the match goes on times. And they earn points by reaching their opponent's outer works, crossing defenses, and scoring boulders in goals. During the following 2 minutes, the other human drivers remotely control their robots. They retrieve boulders and score boulders in goals. Opponent's courtyard. The first time, the baselines will turn on, indicating that defensive strength is reduced. On the second crossing, all lights turn on, indicating that defense is considered damaged. Once any 4 of the 5 opponent defenses are considered damaged, the outer works are breached and the Alliance receives points. Human players deliver boulders to their secret passage through the castle wall. Alliances may have only 1 robot at a time in their own courtyard to defend their castle. As boulders are scored, the tower loses strength. Once enough boulders are scored in the opponent's tower, the opponent's flag will drop, indicating the tower has been weakened and can now be captured at the end of the match by surrounding it. During the last 20 seconds, robots may extend to reach the tower rungs and scale the tower for additional points. If an alliance captures their opponent's tower at the end of the match, their flag is raised and the alliance earns more points. The alliance with the highest score at the end of the match earns the win. Step into your castle, proudly raise your team's standard, and face the challenge ahead of this year's FIRST Robotics Competition. FIRST Stronghold.
All right, so points to the game. Their defenses, so their barriers that the kids have to design the robot to get through. There's one barrier that's always there, and that's called the low bar, which is 16 inches above the ground. So you have to be able to go underneath that if you want to guarantee access. There's some other barriers, like there's a gate. We've actually got examples up here that we made out of Legos. This is the boulder. You get to carry one boulder at a time, and you have to go outside the courtyard with the boulders are outside of the courtyard. You have to bring them into the courtyard in order to score the points. And then the tower is weakened by putting boulders in it, either through the low goal or the high goal. And once it is weakened, you can capture it by surrounding. So their strategies should be one of these three things. Okay, so we're going to have the kids come up and present to you guys. They've each got a short PowerPoint, and then at the end of that, we'll have a question and answer session, and then we'll go ahead and go. Okay, so first up is Brianna. I don't know the name of the robot or the robot's team, but they will come out and present it. So Brianna. If you guys want to come up, there's seats up here that are open and available. You're welcome to come up and sit.
Hi, my name is Reynolds. I'm the leader of this design team. And previously called our robot company Dragon is going to release this year is Magic. And there's like Puff was a good name because the dragon that was by the sea. And dragons are cold, so do that. So who are we? We're going to present ourselves. I'm Brianna. I'm 18 and it's my senior year. And I've been a part of this team for 2 years. Everyone, I'm now with on I have an opportunity to speak my question. What would you say to you?
The question is also supposed to be honest. I'm good. I'm good. I'm only thinking of the I'm just not on this is if they're hearing about it. This is my first year.
So our drive training is right on track drive module, and this is going to be a traction because it's extremely dry. And traction is also very good because you need it on the field, along with getting over from other fences. And thinking the bonus is it has efficient turning, which is a clean turn. To be exact, where you move and place, so you can back up, turn, and not like going all the way up. It also has good sense of balance and great flexibility.
This is the intake and the launching. The intake has a fair development that's powered by unitary mode, and the conveyor belt is made out of relatively the food processing has been good, and other people have said that they have been able to that they work really well. So the ball don't be and they do launch is has to be information of the robot, and when the ball comes in contact with the shoot out you will use the ball by using the fuel lines in the stage, and the angle of the shot will be differentiated to the speed of the wheel.
So this is the universal arm. It has these called linear bearings. We call it things like studs. Yeah. The purpose of this one of the robots is to have support which are the garbage departments and the shelters. There's a big baseball lot is 3'9", and there's a short baseball, and that's supports and they'll have a big motor that is the arm on it, and the arm has the shape of it, so it can open it.
So the first defense team in the class is called a workplace. It's basically the only that you can have. So these are universal arms. These are sideways and put it parallel to the focus on the ground. And they put it into the ground focus and then we will put it onto the back of the robot where the ball is going to slide off the ground. Next up, we'll go to the ball to create a series of 4 seesaws that are set on the field of traction. And it's hard, and what we're going to do is we're going to ask it, basically we're going to pick them up and go to the side with one of the seesaws facing down for the house. And we're going to use this arm or as though we're going to do the pick. So the one next to us, next to it, that's just they go facing back to the front. So you need to get it. Next we have the topic, which is a new topic we also use this special and then we have the order at home defense. Universal arm internal system. Those put on more active so that they come back to the conscious and that will give us an how do we work with respect to the asking or looking for the over at this and what the is how do we check before the first one, but I'm sure go back there and without one and three officers.
So here we have a team 2220, and they're still welcome. And they were on 3 days, and they're using a lot like ours, this happened was level 3. And we want to show you this because that already can work. We're not going to get violated there, and they also go through all the codes and just rolling through there. But I just want to show you that. Yeah.
First thing we do for each actual competition is to be able to give a host of borders that called, you know, we go through one to that what people do go back to the ball. So so there's one. You have to use the fire, you have to the one, four hands. You say this right here is the person so what you all this is what we call the this is what here is about 11 feet away. And myself, if I can do this,
So, like you can see, we have a few backup plans in case some of our designs don't work, either while we're in the robot or while we're actually in the game. So, first of all, if we find out that the Rhino tracker is on hold, doesn't work for our robot, we have a backup drive train, which is just a basic forward drive train with high grip tires, which provide a very good for traction, like that. And it direct drives so that the motor actually is wheel and uses gearbox. If we're able to shoot at high volts, say one of the motors that the wheels stop working or for some reason with the wheel, we can still shoot the rolls. We intake the ball as usual using conveyor belt, but we go up the roll and then we just reverse the intake and shoot it to the roll. And if none of our shooting works, then we can still cross the fences and get close to our lines while they shoot. And the tricks that I'm chosen, they're good for the terrain, which just depends on how they scene. But pretty much just have those steel cubes that are each and a half away from each other and aren't really 2 inches wide. So if you roll that, you roll that. And our last resort is to defend our goal from other robots and maybe assist like other teams getting them all to reach. And here is our complete robot design. This is most of the that here it is. For like a couple of different views to look at it. And in our presentation, we just wanted to say, like Mr. Joe said earlier, we really love being robotics. We love having fun. We're trying to do creating things and learning. And none of it would be possible without our community and our support. So we just want to say, thank you, Harbor.
So what we're going to do is they're going to bring out posters when all 3 teams are presented, and we're going to have a question and answer section then, where you guys can go around and talk to all the teams. Okay, so let's go ahead and get the next team up. And you guys can gather. Okay, so next up we have Cameron's team, and I don't know the name of the team or the name of the robot. Cameron has his own laptop, so that's going to take a second to set up.
That would seem more simple.
Easier execution. I think that's true.
Easy to understand.
They designed teams is actually better before. There was a high time.
So this team wraps up. Yeah, I'm free. We are also streaming live.
I'm sure I got you. This is going to be a sense of humor. Oh, this is the one
So Rachel was the president of the team year before last, and the vice president of the team year before that. She filled in forever, now she's studying bio, molecular biology, and physics. So we need to.
Yes, so our robot is designed here is called physics and 1955 is also their lab working.
Sorry, can you get this microphone?
Okay, sure. So myself, just Caroline, I'm in Philippines, Nick Powers, kilograms, and Maggie Cappers, and Q Whites, who was a video member.
So our strategy is to play offensively, focusing on regional defenses. You'll be able to cross every single one of them. We have one high goal scoring capabilities, as well as maintaining an option for robots to then robots and better offenses for them.
So, the piece that is the magic block has that. Then it's simple high class and improving the ability to find the structure and all the things opposite
process, one calls for things castle, sport points, and the criminal offenses. This project is complete and is designed to be accurate and capable of a high quality manual and designed by our colleagues. The following enhancement also particularly in the global.
So the point now. The first 15 seconds begin with the autonomous. This is when the robot will accept no commands from its drivers. We believe that in these first 15 seconds, we can acquire 2 points for reaching limits and 10 points for crossing the robot for a total of 12 points in just the first 15 seconds. The next 2 minutes and 15 seconds will be the teleoperating period. This is when the drivers can control the robot. We believe we can score 10 points in the tower, which will remove 2 strength in the tower, usually at 6. We also believe we can score 35 points in crossing the fences with our allied robots, which will give us 1 making point for crossing 4 fences, for a total of 47 points and 1 making point in the tower.
So most of the vehicles that are built for robots, we actually already have one. So the speed robot would be relatively inexpensive to have.
This voting otherwise is just.
Because speed robots. Without you guys, it would be impossible to do this. We would like to thank our sponsors, our community, as well as our families who let us stay at this club for ungodly hours, and the school who lets us even exist. So thank you. Okay, so, the motion and mechanism, it's a little complicated. You're doing in the time of yet. So, one of these features, and then we have so instead of using these rubber bands, we're going to have this cage. So the cage, we're going to put this cage onto a motor and run this thing. Yeah. And it's going to push the cage out through the telescope stand into that thing. And all the way up. And hook up. And we're going to wait. And pull it. Pull it all the way up.
The fact that this group came up here twice and had their PowerPoint not work out, and yet still they presented, and we as an audience, I believe, have an idea of what we're talking about. So, and before this comes back, this is the most well-invested I've ever been at one of these events. And that is because Michael really loved robots, and Cameron did the other. So what we do, I brought 4 robots this week for presentation with all from this. This year's is the most of the drawing. So instead of just spending all my drawing over and not sleeping for 2 days straight. This is amazing. So we're going to have a big set of tons of boards across the room, and then I'd like for you guys to get up. I'd like for you guys to get up and walk around, feel free to ask your questions, talk to them. We'll let this go on for about 15 minutes, and then we'll get down and see what we'll have in conversation. Okay, so the kids are going to set up their lifters, get up, move around, talk to them, and ask them questions.
I'm not going to get feedback.
I know.
So how does this robot?
Just get another robot's way. We don't really have a way to block the angle, but we can just definitely stay with locals. What's in there? We shouldn't have to do that unless everything breaks. So hopefully not everything breaks.
You got a plan for everything.
Yeah. No, this is a wheel that we'll use in case this type of thing doesn't work. We're going to use a wheel like that in our robot. So that's the backup plan. Yeah.
So with your universal arms, does it just pivot or does it also go?
Two, what's it called? Vertical. Okay, I wrote it down. Yeah, 2 degrees of freedom. So I can go like that, the arm, and it can go like that at the same time. So like,
What kind of mechanism are you using?
I told you. So what we're gonna, we can't really, it's actually not on this patent model. It's not an artist's rendering. It's not as accurate. But there will be a sprocket here, and a sprocket here. There'll be a belt that'll attach both of them, and the sprocket down here. Well, yeah, we have a little hand-drawn thing that we drew earlier in the game. That's also an early drawing. Some of the motors are in certain places. Yeah, everything in places. But but the motor, using the motor attached to the sprocket on the bottom, which the belt will be attached to, which will be attached to that thing, and make it up and down. Where's the ball? The ball, it goes kind of in here. You have an adequate view of it, but these belts will be turning inwards inside the robot, and the ball will hit this, and then it will hit that, and it'll be. And have you seen that work on other robot designs? Or like,
So will it just sit in there, or will it actually be captured in there as you go over some of your obstacles? What are you going to do to make sure the ball doesn't just roll out?
well, the opening that it goes through, the ball's 10 inches in diameter. You can actually squeeze it to make it smaller, which is what we're going to do. And then once it gets like sitting in here past that, and just sit there until we decide to turn on the luncher. So I'm going to stop answering. You got to go now. So you're going to answer the next question.
It's a live stream. So sorry that your guys' presentation didn't go well, but so this is where you guys incorporate into this design. What exactly defenses are you planning on going through specifically?
Okay.
You know what the names? I don't know.
I know some of the names.
What they all look like.
Okay, so there's the gate one, which is the protocols, right? Okay, so the gate one goes like, we're going to use the arm and we're going to lift it up and we're going to
The fourth part is going to go 4 and 5 and 10.
I'm explaining the defense. You don't need to explain. I'm explaining that. You can do the one where you have to push it through. You can do the drop rate where it goes down. We can do all the like moat ones and like little cute thingies. And whether the weird rock wall thingy, and the low bar for small. That's good. Small is good.
How much the robot going to weigh?
We didn't calculate that yet, but it's going to be less than 120 pounds.
It should be less than 120. I'm guessing like 90 or 100. It's not going to be too heavy.
Which is going to be really powerful. That's going to be
There is another backup. Oh, okay.
Hi.
The trends, I believe, are 3.5 wide.
Oh, yes.
They're wide.
So this has rollers that spin. Drive up the ball, they just kind of suck that. Yeah. This.
So that's what our
Yes.
So these are structures in inwards to wires.
This is actually a pretty common method of collecting balls.
There's going to be individual
We can have it on one motor. Well, one motor to move the assembly, and then we can have another motor that is.
It's all good.
Yes.
And what part is the mechanical?
Oh, it's this parts.
Oh, I should have right. Okay.
Yeah.
How do you get it into your account?
We have these rollers that spin and suck the ball up when we drive up to it.
Oh, okay.
It's like one of those like, you don't watch it. Valerie. Below on first go to the feedback at all. Then if you reverse the direction of it, that suck it in and just go right back out. I didn't actually.
So far, I got no one questioning you guys in life.
No, we don't because we didn't think we'd have the time for that. So we didn't have our robot components. We had some methods of doing that, but also to actually take the tower to capture it, like it's just in that video. You don't need to be hanging, you just need to be on the base of the tower. The silver part of it to capture it. Some of the robots can hang, and that gives those robots individual points. But for us to our whole lines to capture the tower, we have to be at the base of the tower. I don't know to be able to support our robot because I can support like trying to pull the portable skate up or pull a thing down. Those don't take a lot of force actually. Pretty lightweight. But our robot, the weight limit is 120 pounds. It can be that heavy. So imagine like this little thing lifting up this.
So, quick question about your design.
Yeah.
If by any chance, can you guys like put a design to a point where, like, if that universal arm can fold so that, like, it can go over under the logo or something like that if it were to fit?
We could do that. We considered kind of trying that out to present to you guys. But we wanted to focus more on making sure that our arm and our shooter were really stable designs and everything. But we could probably figure out how to make it pull down so we could go under that low bar that they showed in the video. But as our robot stands now, we can go through at least 4 defenses, maybe even 6 of them out of the 10 or out of the 8. So that's pretty good. Yeah. Answer your question, Chris?
Yeah, I'm good.
Cool. All right.
So we're gonna take it apart. It has a little whiny thing in it. We're gonna put a motor in it, and then so we have a bunch of tape measures. We're gonna like double up the thingy so it's super supported.
That telescopic thing.
So the motor is gonna be inside the tape measure, and it's just gonna rotate. It's gonna just like push it out.
Okay, so surely it's not going to go out, and then it'll be up this way, yes, and then it'll hook. It's going to have to come in, and then when you basically like reverse it.
Well, no. So we're gonna have it do that using Velcro, so it's just gonna be able to pull off because we don't think the tape is just gonna be powerful. Pull the entire robot up. That's what the winch is. So our winch is like easier, like pull it up. So it's gonna be on the hook, and then it's just gonna like pull. It's really powerful.
All right, that makes sense.
It seems only 4 feet wide. I was rather robot.
About time.
And then today, when we made our prototype, we took the whole thing and just shoved it around like this.
Right, right.
It's very tightly.
Good. While you're driving around with mouth.
Especially when we go over the bumps and stuff, it won't end up
And then looks like this one will go on below that 16-inch like there. Will go into that.
So we were deciding it. We're like, hey, our robot can do this. Yay! We're really excited about
Bitcoin live stream. So I have a quick question. Where exactly is your intake?
What exactly is the intake? Or where is it?
Or yeah, where? Where on your drawing?
So yeah, so there's 3 bars there.
Yeah.
And those can both intake and push out far the balls so that we can take them into our catapult
Yeah.
and push them into the logo if need be.
That's great.
The only time when that mechanism will have to be down and not holding the ball in there is when we're driving under the fences because it seriously shrinks the size of the robot when it's down and wants to start shaking. So that would only yeah, so it rotates down. No, it's rotating inwards forward. That's what gives us the capability to how
The one of the drivetrain? Yes. No, that just demonstrates what our drivetrain is without using a CAD file. It demonstrates the fact that we, in fact, using the radar track allows us not only to have tank driving, which are good at offroading, but also it has that knowledge up so that it can also help us drivetrain as well.
How is it looking up?
No, they should be very. If we can make them correctly, then they should be great. If not, we have a four-wheel pneumatic, or four-wheel drop pneumatic drivetrain as a backup, which is 4 wheels, 2 on each side that are dropped, and then 2 on each. 2 on each, 1 on each corner that's phased, which provides pretty much the same thing, but we've made it before, and it's slightly worse in being able to drive the train, but it's still really good at it, and we've made it before, so that should be.
That is one of the problems. Once you flop it, whatever it is, it's going to hang on.
Just let people demonstrate.
Any other questions?
So it's a catapult. Looks like I don't know, some kind of cup that's just it's a catapult, right?
Yeah.
Okay, makes sense.
because the width of those rough terrain obstacles that we have got right, there's one that's a whole bunch of cubes, and there's one that's at this tall. And these treads right here, their highest point is 9 inches. So they'll be able to easily go up and over that 4-inch point.
Sorry.
Yeah, because
I feel like that would be slow.
You know, like, see, I can see what you're saying. Like, you know, it can be that tall, but itself up. I don't remember exactly if it actually fell.
The problem was if it got too short, then you just crash down the robot. That's like but also the thing about a straight line, so how can you the particles will not be down on the robot in the very front? How can you make sure that it's not going to come crashing down on the robot after it has gone over this?
See, that's why this thing's here. So basically, it creates this gap in between that short part and its back. It's basically calling it the hang.
There's someone online that wants to actually lift the robot.
And then crash on the floor.
But I still think it's okay. I feel like it was and if I was able to lift up so that it would lose.
I'm sorry, but I'm going to have to ask you guys, the team, not the adults, to step outside so that we can have a quick discussion and help figure out what we're going to build. All right, so team, thank you very much.
I'm gonna have to sit here, guys. Yeah.
Let me move up these obstacles.
Okay, let me put it in this way.
Oh, now let's put them in front of me.
Well, sure, but I need to put the.
Sure, the back is better.
I think I need something to hold this up.
Okay, so we can kind of get it back up again. So the way in which this section works is we're going to have a kind of really brief just questions, and then we are going to, the way in which you vote is that you stand in front of the design that you want us to build. Okay? So first we're going to have a discussion where you guys can kind of sort of ask questions. I will try to answer them in the least biased way possible. So, does anybody have any quick questions about things that the kids said, things that you guys see in these designs, things that you guys think? Does anybody have any statements? Any sort of... Okay, so the tank tread drivetrain that all of the teams plan on using, we do not have and are out of stock. They will not be back in stock for 3 weeks. So we have 5 weeks left to build the robot, and the kids really want to use a drivetrain that they won't get for 3 weeks. 3 weeks. So the alternate plan is to use 8-inch pneumatic wheels. 3 or 4 per side, which we have in stock. So just know that that is an alternate plan instead of using the tank treads. Is that okay? Any other questions? Yes. Okay, so I believe it's 4 for the treads. And those are 4 of our biggest motors that we're only allowed to use 6 of. 6 of, and actually if you use more than that, you break the main breaker. And then they're using 2 smaller, they're called mini sims, for the shooting mechanism. And then really only take like 1 motor to move the belts, 1 or 2 motors to move the belts. And then, do they have a tilting mechanism or is it always in a fixed angle? At a fixed angle with 2 window motors. So it's 2 window motors driving the belts. Oh, sorry, 2 window motors driving the arm that lowers the defenses. Okay, so that's a lot of motors, but that many motors stay under our power limit.
2 years ago, we had something like catapult. That was a different design than we did 2 years ago.
Okay, so the catapult design is slightly different. So the catapult flinger ball, 2 years ago we had a flinger
They form a big, it's a 2-foot diameter ball. It's a lot heavier than this year's ball. We actually never, did we use it? We never used the flinger in competition because it was too slow and it was difficult to get the ball onto the flinger arms. They believe they've addressed that by loading the ball directly onto the flinger. So before we had, like, we lifted up the ball and then we transferred it back to the flinger and then we just kind of drop it on the arms and then move all the stuff we used to lift it out of the way before flinging. This uses a roller and to roll the ball onto the basket that launches it. That said, it's still a flinger arm that uses pneumatics, so it's the same technology for flinging. It was pistons. It was pistons. You're right. It was pistons and elastics. So we ended up using pistons and stored kinetic energy using rubber bands. They were actually bungee cords that fling the flinger faster. This, I believe, would just use pistons. Yes.
Is there a possibility on the ball to fall out of it and get stuck in the machine?
I asked that question when I went up to them, and they have their collection mechanism comes over and it holds the ball into the flinger. So to hope that they prevent losses of the ball.
No, they may be done. So if it gets stuck in there, then they would drive around. Yeah, coming through the fence. I would say so. Yes. Okay.
You talked about the advantages of being able to use the low bar and push at the robots that you don't use the low bar.
So the low bar is the one defense that will always be there. So every match, the low bar will always be there. It's just a low bar with a mat hanging across the front of it that you can drive through. These two robots are designed to go under the low bar. This robot will be too tall. Cameron's robot came on the low bar, right? Yes. Okay, okay, I'm not positive, but I do believe that these two robots can go under the low bar. The other, yes. I would say that the accuracy will probably be about 50%. Fine, greatly dependent upon driver skill. One of the things that we have had talk of using is a flashlight, aiming where the ball will go when they launch it. And so basically the driver can line up the flashlight with the target and then shoot the ball. I don't know how easy that would be with a flinging mechanism. I think with the flinging mechanism, you're going to have to be at a fixed point every time you shoot. With this robot, there could possibly be slightly greater variability in where you could be when shooting. Does that help? Yes. No. So you're allowed to use lasers, but they have to be a really low class of laser, and you wouldn't necessarily be able to see it from the driver station. The driver is going to be 54 feet away, 52 feet away from the goal when you're driving the robot, and there are defenses like the gate and all those other things in between them and the goal. So it's confirmed that you can see the top of the tower from above the portfolio. Yes, you can see the top of the tower, but you can't necessarily see the robot if the robot is short. Okay, so all of these are shorter robots, and the launching mechanisms are low, so they won't necessarily be able to see the robot when they're shooting. So they're going to need some sort of aiming mechanism. I said flashlight's a good one. Does Mallory have a question? We're having a volume problem, sorry. Okay, yes.
So on Brianna, they had a, because we know the Rhino drive that they're going to have to construct because we're not buying the pre-assembled Rhino drive. So, but she had an alternate drivetrain.
They all do. It's in that case.
Oh, but she was the only one.
Okay. So yeah, so it would be either a 4 or 6 wheel or 8-wheel pneumatic wheels, so wheels on your car, the air in them that we will have filled with foam so they can't go fly. Yeah. So the way in which we would design the wheels, they would fit right where the anchors are. Yes.
What's the triple for the unicorn? How fast is it? Is it so fast that you'll just go straight into a wall?
All right, that's it.
And just break
Okay, so robots are all using the same drivetrain, so they should all have relatively similar top speeds. The fastest robot we've ever had was about 27 feet per second at top speed. I think I saw something online with the pneumatic wheels at about 18 feet per second at top speed. I don't know what the tank treads. Okay, so with the tank treads, it's about too fast. Okay, so no, we won't be hitting those. Yes? No, this is good. This is your job.
So if we change from the tracks there to the wheels, does that mean the machines get lighter?
We'll go with the box. Oh, you got 1 and then 2. 1. No. So the goal would be to keep the machines the same size and just instead of tracks, wheels. Okay, wait, hold on. We got 2 and then 3. 2. They are. Yeah, I mean the kids. They have a camera. So, well, sorry, I shouldn't address that. The camera systems tend to lag because it's over Wi-Fi. So in the past, when we tried to use the camera, you move the robot and then the video feed updates like a second later. So it's like you're driving a second in the future, and it's kind of hard to drive that way. So yes, and actually we've tried to use like to automate it so the computer would look, and we use the camera. So the computer looks through the camera and says, "Okay, here's where I am." But even then, there's still lag, and that actually slows the system down more because the processing goes up in the robot. That's accurate. Yes. Okay. Perfect. Okay. Great.
Just wondering, is there any parts that could just fall into different parts of the robot and mess it up?
We try not to let that happen. So the question, I don't know if you guys can hear that, the question was, are there any parts that can fall into other parts of the robot and mess it up? So we try to build the robot so that they don't hurt themselves. Okay? This robot does have the flinger arm, and the mechanism that brings the ball in kind of sits over the flinger arm. But we have checked the, I'm using the word kinematics, so we checked in the computer, and that's how we design things. We check in the computer to make sure that the robots can't hurt themselves. Does that help? Okay. 3, and then 4, and then 5. So, oh, sorry, wait, hold on. 2, 3, 4, 5. 2. Mm-hmm. So the way that would work is the conveyor belts would reverse direction, pushing the ball into the wheels, and they would roll the ball into the logo. Okay, so this robot is using the conveyor belt to feed high spinning wheels that would shoot the ball. I believe they can also reverse the belts to shoot for the logo. This one is kind of limiting itself to the logo. No, sorry, that's not a bad thing, because if they can score the logo quickly, they lower the tower defenses and then they can storm the castle. Okay, so we had, so we went this way. Okay, there we go. Ranking points. Okay, so ranking points, there's 3 ways to earn ranking points. You can earn ranking points for breaching 4 out of the 5 defenses. You earn a ranking point for that, regardless of the outcome of the match. You earn a ranking point for capturing the castle, and then you earn, I believe it's 2 ranking points for winning the match. So a team can specialize in breaching defenses and earn, like if they just, okay, every match we're going to breach 4 defenses, then they would earn 1 ranking point per match, regardless of whether or not their alliance won the match. So a team that specializes in breaking defenses can earn more ranking points than a team that specializes in shooting. Now, where that comes into play is after the qualification matches, the teams with the highest ranking points go on to the finals. So you can win every match point-wise, but have all your defenses breached and lose your castle every match, and not win ranking points-wise, and therefore not go on to the finals. And then you get points for competing in the finals that take you on to like the next level. So first there's a district level where we compete against other high schools at high schools. Then there's a state level where we compete. It's actually 2 states. It's us and Oregon. And then there's the World Championships, which is where I'm with your help, right? So then we had Eric. Okay, so the high goal is 5 points, the low goal is 2. So you have to score 2.5 points in the low goal to equal 1 in the high goal. Now there's one of the things we're talking about in terms of strategy is cycle time. So it takes the robots a certain amount of time to drive across the field, it takes the robots a certain amount of time to get through a defense, it takes the robots a certain amount of time to score a goal. I think that the Bighorn Unicorn, their focus is on really fast cycle times, scoring the low goal, whereas this robot's going to have a harder time getting through some of the defenses because it has to use that arm, so it would have a longer cycle time, but hopefully be able to score in the top of the castle.
In addition to the point difference, so both the high goal and low goal between the tower by the same amount, so another point of scoring is going to be to the tower enough so that you can capture the tower at the end to go to the
So did that help? So once you get enough boulders to the tower, regardless of whether they go on the low goal or the high goal is 8 boulders, then you can capture the tower. You can't capture the tower unless you score 8 points.
Do you remember how many points they can get just for crossing all these defenses?
I think it's 5 points per defense. Okay, so then it went kind of this way. I lost track of it. So
You have to answer mine. Regarding cycle time, each of the teams indicates that they could cross 4 or all 5 of the defense categories. How likely is it that they're going to be able to successfully, given the 2 minutes and 15 seconds they have, how many realistic breaches are they going to be able to do per match?
okay, so this robot really specializes in breaking defenses, and I believe 500 Unicorn also specializes in breaching defenses. This robot is more limited in the number of defenses that it can breach, and the defenses that it can breach, it takes slightly longer to breach.
That's 4 out of 5, just like this one.
Oh, never mind then. I guess it does 4 out of 5. This one does 5 out of 5. Okay, so so the robots are teamed up into groups of 3 for each match, and it's random grouping of 3. So if you're in a group of 3 where your robot is the best robot at breaching defenses, you would probably spend 2 minutes and 15 seconds breaching defenses. So in that case, we want to look for a robot that can breach defenses quickly. If your robot is the best scorer, then someone else in your alliance would go breach defenses, and you would basically go back and forth shooting both. If both of the robots on your alliance are better at both those things, then you want to be able to support the other 2 robots so that they can do what they need to do. So you would perhaps go get welders and bring them to the other courtyard so that they can be scored. Or you would help breaching defenses. So for example, the drawbridge, one of the ways in which teams are doing that or planning on doing that is having a robot drive through and then back up, opening the drawbridge so that the alliance partner can go through. Right? So there are ways to get around the defenses if the teams work together. Okay, so we are running short on time. So I'm going to let Ernie ask a question, and then we are going to stand up, and everybody's going to try to go where they want to go. Okay? So
During the competition, the team has a scout to go around all the teams. They don't get the same ones during the match. So they don't look at the strengths and weaknesses of the other robots. So when they come up with this, they go through and say, okay, you can do this, you can do this, or we can do this. So it works as a team here. Whatever we choose here, we try to do the best we can with all that we can. But if something breaks down and ours doesn't work, then the other teams are going to, what can you do to make sure you have to do that? So it's all a matter of.
okay, so Mr. Hunt?
That's all one question with regard to the high roll and low roll. Is there anything that essentially only is like what we're doing? Lock, low roll, on parking.
Okay, so yes, and we actually were really successful one year, just driving around hitting the robots that were trying to shoot behind us. So I have a feeling that's going to be happening quite a bit. There's a vendor has been on several teams that are really successful. He came out on Wednesday and talked to the kids, and he said, be ready for teams to drive across the field and smash your robot, especially when you're trying to shoot. Okay, so we would love for you guys to get up and just stand close to the poster of the robot you would like to vote for, and then we will let you guys tell each other why they should move from wherever they need to move.
This one over there.
All right.
There's a scout.
Oh, great.
Yes.
It seems to me everyone likes the twin unicorn.
Yeah, well, I definitely like its logo.
Looking at it, yeah. Well, you're not supposed to touch the. I didn't read the rules specifically, but it didn't say in the rules that you're not supposed to touch the ramp of the tower.
No, you can drive up all night.
Oh, well, touch it before you score or something like that.
Yeah, go ahead.
No, I'm just wondering,
I
like,
do like about that robot that it has the ability to pull it.
how does that climb? I can't tell by design.
Oh, it's not so you have something to go up and climb, pull down.
Oh, 50 points is better than none. Oh, God.
Okay, so each team needs to elect a team representative. Just so that you guys can figure out why you chose what you chose. Okay, so real quick, this looks like a relatively big group here. You guys pick somebody, and real quick, just decide why you chose what you chose, and then you can speak up about it, okay? So, 2 minutes.
We can talk about that.
Okay, so the only person who was on the stream was Mary.
Oh, cool.
No, because I know how she was talking.
Volunteering part starts.
So, do we have a representative over here somewhere? I'm not representing. I'm holding a camera here. Do we have a representative for this group?
Very proud of that.
Okay. Do you have the standing representative yet?
And it has the ability to shoot the rifle as well. Best speed,
So,
can make more round trips, that's more useful.
so has everyone come to a consent of who is the representative?
Yeah, it's expensive. It's more realistic.
Okay, group leaders, you guys have a pretty good idea. Okay, so since you guys are the biggest group, we want to start with you. Since you guys look like the smallest group, why don't you start?
Oh, no, don't do this to me, bitch. Alright. Alright. I hope you guys have 5 minutes to talk about large figures. This is Shane, and it's relatively cheap because they have most of the parts already. So, in terms of budget, it wouldn't take too much. And, in fact, you have an alternative plan that this can work out. I feel like this is more flexible than the, I don't know what it's called, Twin Organic Marvel, and the Puff Magic Dragon, because that was dedicated solely to logos. And this can shoot high goals, but I feel like the amount of time it would take with the magic arm and like the mass arm that it has to take down fences is just superfluous, and a lot of them has an abundant amount of motors, which is concerning because that leaves a lot of room for error. Yeah, I can go through all the goals, especially the logo. And they have really moderate compared to that, which is relatively slower than this one.
Awesome. Thank you. All right. Next up, because you look like the next biggest.
Okay. So, one of the main features we like about this particular design is that it has the ability, it's the only one here that has the ability to shoot both the high one and the low one. So if there's some issues, or one of them proves to be more difficult than another, or there's a defender there that's aggressively, say, guarding the logo or parking in front of them, this particular robot can elect to shoot from the top instead. Or if the bottom goes open and that's quicker, you can go that route as well. Universal arm design on this allows it to traverse a lot of the obstacles, which is, I think, similar to all the other robots. And since they all have similar drivetrain, I mean, speed-wise, they'll all do the same thing. The main thing on this one that's better is the advantage of being able to shoot both behind.
Okay. Thank you.
Okay, so the reason that we do this is because it is lightweight and it's fast. It has the widest treads out of any of these.
They're all the same treads.
They all the same treads?
Same treads.
Those are the widest. Those ones are saying like 2 inches. Those ones are saying
They're all the same treads. They're all the same.
well, they lied. So then going on that, this one is the shortest. This
Nope.
No?
These, that's the
Same
shortest.
size? Okay.
That's the shortest.
Shortest, quite shortest. Well, this one is very light. It is fast, and it doesn't have as much room for air in the way that it holds the ball is inside, so there's no way that the can ram into it and take it out because of the friction. So conveyor belt down, well, is that, I know trebuchet is really epic, but like there's a lot of room for error, like how it can fall out. And if it was bumped in a certain way, since the ball is very light, it's very easy for that type of ball to bounce out and go out of the trebuchet. Whereas this one, the giant stick on the top does not make it able to go under the low bar. So, and that is the defense you're saying, that is in every single one. So so if all the other ones are taken because of its relatively slow speed compared to the other two.
They're all the same.
They're all the same speed. Well, that's not telling that this is slower than I'm sorry. Okay. So no, but so continuing with that one. As this has the lowest, only goes to the logo, it is still capable of going relatively fast.
Because it can, so the reason why this one, the reason why they tout the cycle time of this one is because they're not going to bother with most of the defenses, I believe. So I think their goal is to get balls, drive over to the other side, and deliver the balls into the low goal. There are several defenses that they can get through quickly, but they're not going to really bother, I don't think. That's not the main focus. So the main focus of this robot, I believe, is defenses. The main focus of this robot is, I'm going to say, scoring in the low goal. The main focus of that robot is a couple of defenses and scoring in the high goal.
This robot also is the only one that offers the possibility of the climbing mechanism, but the climbing mechanism doesn't work.
Okay, so does that help clarify things?
Another thing to clarify is all three of these robots have the exact same drivetrain, so they will move at the same speed.
Yes.
And they will have the same pushing force, and they will go over terrain.
So all of the terrain-based obstacles, they will all be able to get over. Just the obstacles that, it's actually just the low bar, I think, that this one would struggle with. Nope, that was designed for the low bar. Okay, so with that said, does anybody want to change alliances? Does anyone want to move? Oh, wait, hold on. Okay.
Okay, so does anybody want to change where they are standing? Okay, and then see you later. Okay, guys. So now we are seriously running out of time, and I'm sorry. I don't want to keep you guys late, but I really hope you guys are as invested as I am in the right robot. So I want each group to talk amongst themselves and see if there's something you would like your group to change about their robot that you think if they made that one change would win everybody over. Besides, like, we want them to just build a robot that wins. So if they could change one mechanism here, what would you have them change that you think would get everybody to go over you? Same thing with you guys. If they could change one mechanism here, is there something you guys think they could change that would get everyone to come over to you? Same thing with you guys.
If it's okay if I can suggest something, even though I'm not part of this group, maybe you can actually ask the group if this design were to be picked. There is this hanging mechanism I thought that can actually pop out of the frame itself. That it's actually pushed by a piston. That once it's out, it can actually pull itself up by extending and then retracting and then closing back in, and then if it folds back into the robot, it actually folds the robot onto the tower. Where the fact is, the referees can prove the fact that the robot's hanging on the tower. All right. Well, if a catapult doesn't work, there's always a shooter. Like, you could switch it to that because there's a lot of reliable shooters out there. Especially if you look up a couple years ago, look for the game Rebound Rumble and see how robots use basketballs as a shooter. Oh, okay.
And then, if we take...
Because these are softballs that can actually go...
Right, but I think that's why
Okay.
going to stay
full score in the local competition.
Okay.
Put the balls here and just back up to the local and then
I mean, could they not just push it?
Well, it can't. It has the advantage of going to logo too, right? If the motor were to get attached, yeah. If those arms would be sticking out all the way, they can like keep the ball like a soccer, like with your feet. You can keep the ball inside within your. If it stays down all the time, though. Any suggestions like where if that long arm can actually retract, like go part of the frame, but then it extends as it goes up? So like, give me 1 second. So like you went up and then there's something attached to that extension up or down, something like that, and then if you go back down to the next fold. Yeah, so that it'll have an advantage over each of those. It had an extension.
That's what he's trying to do. That on the robot.
It's just it was a suggestion. I don't know. Looking at the design, maybe it was odd. Since it has that on, maybe why not retract that on too?
Think it like a cable. You push back on the cable, bring it out when you're done pushing back, and then you can go under the little arm, right?
Yeah. So has.
Okay, so do you guys have your ideas?
last the first time. You should go first this time. Do you guys have a spokesperson? Okay, cool. You're up.
So
Hold on. Why aren't you on our team?
I want to be.
Okay.
Like they're coming.
Yay!
Yeah. I don't know if I want to film this whole thing.
It's okay. You don't have to.
Okay. So the thing that we don't necessarily have anything that we'd like to add, because the thing that is beautiful about this machine is that it is the simplicity of it. There leaves a lot less room for error, and if the students and a lot of focus on what is already here, then they will have a lot more of an advantage against the other teams who might have a lot of extra stuff that could go wrong, because when we're talking about stuff that runs into each other, this is the most approached one for it to not fall apart. If that one, or it seems as it seems, it's going to not fall out of the game.
Awesome. Thank you. And yes, they're coming. Okay, you guys over here. You guys have somebody. Okay, so what? So do you? Is there a different kind of shooter that you would? No, but so there's basically 3 types of shooter in the room. You've got a shooter that uses spinning wheels to shoot the ball. You've got a shooter that kind of uses a belt to spit the ball into the low goal, and you've got a catapult. Yeah. We hope so. I will say yes, it should be able to shoot into the low goal. So you're saying you'd like to change the shooter? Okay, so you'd like to change the shooter, okay, to maybe like a spinning wheel shooter or maybe like something like that. Okay? Over here, what would you guys like to change?
Yeah, that's the one. This is the clearance and the low bars on every. They're on every event, so it'd be beneficial to do that. I think if you borrow elements, either one of these two, which have manipulator elements that are below the low bar threshold, they could fully cleanse this thing and then be able to rapidly cleanse it. That'll give it everything that you do.
Okay, so they want to get rid of the bar that sticks up and replace it with a lower mechanism for breaching defenses. They're happy as is. And they're thinking of swapping the shooter out for a shooter like that shooter. Okay. Okay, so does anybody, after hearing, so if they had a different shooter, if they had a different lowering mechanism, or if they stayed the same, does anybody want to change their alliance? Okay, so okay, yeah.
I just like to add to that. So I just heard a lot.
Did someone say that they can hold the ball? Everybody can hold the ball. Okay.
So I know that I said that we shouldn't put robots together. That was before I watched the presentations and then changed my mind. So I rescind that statement, and I'm sorry.
Okay, so does anybody feel like maybe we should take elements from all of the robots and put them together? Yeah. Okay, so this alliance is saying no, and I hear yeses over there. Okay, so how do we do this fairly? So here's what I'm going to say. I'm going to give you. This is hard. No, hold on. Awesome. Gabe's a former team member. Okay. Here's what I'd like to do. I'd like to give you guys 5 minutes. Okay? So, who said 2?
All right, so I'd like to give you guys 5 minutes, and here's what you guys can do in that 5 minutes. If you are happy with the design the way it is, awesome. If you would like to switch 2 designs together, then you can argue that out between whoever wants to do that, and then we'll present those to you real quick, and then we'll vote. Is that fair? Okay, awesome. We've got 5 minutes. Go.
Well, I realize that your robot can go under the low part, and your robot your collection. They're simple.
The launch mechanisms, internal right,
Yours is clearly.
You can say that a little louder. I didn't hear you.
so these guys will combine.
Well, it's one shot because you can combine both designs where you have a shooter and then it's something that traps the ball. When there's, I don't know if it traps just looking at the design.
Use those basically stabilizing arms.
Sure. How does it pick up the ball? You know?
It's right here.
They have rollers. This one uses a bigger belt system, so you go up to the ball, and the belt basically suck it in.
That was a former team member, and actually, when I saw the basketball robots, the conveyor belts actually hold the ball a lot more secure than those spinning rods.
This one, like, once the ball goes in, then it lowers so it can't come back out.
Just thinking of the complexity of being able to steer it, to be able to get a shot off at the high goal, it's going to be few and far between.
That's why we just married them.
Right. Exactly. And I like the rails on the top, and the being able to, and then having an arm to be able to, like you've got. I think they're all holding mechanisms. They can shoot at the low goal. And so definitely a plus. These two designs all
They have an advantage over defenses too. They have an advantage over defenses too. At least 4 out of 5 defenses.
Right.
Yeah.
So.
And I just don't want to get scared about it.
Either one of these two. Like the ball launching of that. The part I'm concerned about is the drive. On those drives. And the guys got the 6 months. Actually, 5.5.
Well, the fact that drivetrain doesn't come in until the 3rd week of the build season, that means we have half.
How quick would you be able to switch it to the pneumatic system?
That would mean taking more time being re-inspected too. We're switching from one.
What I was getting at is if you already had it prefabricated,
Right.
Rhino drive, everything.
We would, but the rules say it has to be less than 30 pounds, and I think that drivetrain is more than 30 pounds.
Wait, hold on. So we've had some watching. It looks like going on over here. And it looks like we've had some people think about these guys. So, could you guys just present real quick what you're thinking?
So what we're thinking is we like elements of both of these, and I think by combining them, we can come up with a robot that's a little bit more versatile in terms of being able to do the obstacles of something in
None of these things are cheap. Yeah.
Okay.
Okay, and then over here?
One thought over here as far as matcha, we do like the design of Physics arm that could very easily slip under the portcullis. So maybe we would exchange the arm on this robot for that so that we could very quickly traverse that barrier and be able to do all of the obstacles. Yeah.
Okay, so something that I kind of hear happening is you guys like the profile and the low arms of this robot. You guys like the variable shooter of this robot. You guys like the simplicity of a low shooter. And everything else, though, it seems like if you add those arms, is the same. Wheels.
I would say I look hate having the catapult.
No. So does everybody say no catapult? Okay, no catapult. Okay, so Wheels. Wait, hold on, you guys. Oh, Wheels is up. Stand up on the table, Wheels. Okay, what's up?
So if we have the conveyor belt to suck the balls in from up on I would like that.
Okay, so that could be a low and high shooter on that profile. Okay, and then we just tell the kids focus on the logo. Is everybody happy with that? Are we ready to bring the kids back in?
Wait, what? What's going on? So, you want to know the overview. What's going on exactly?
So you guys want the simplicity of the fast cycle times, so drive up, go to local, but we want the variability of having the ability. Okay.
Are we no longer trying to climb the castle as this one does?
Wait, we haven't taken that out of the picture?
It sounded like
I'm not done yet. Okay, so the main goal at first is something that can get through the defenses with those bars and score the low goal. We have the variability of the high shooter that would be all in one shooting mechanism anyway, so it's possible they can shoot the high goal, maybe they don't. And we add the tower climbing mechanism, which is actually something we've already done on our FEC robot this year. It wasn't, but we bigger motors. Okay, would that make everybody here relatively happy?
So, are you just saying that we are going to have this robot that we're going to use shooting thing for that one, and we're going to switch out the arm for that?
Yeah.
Okay. So how are you going to keep that under the height?
Because I believe.
Yeah, that's a.
It's the arm. It's the arm.
The arm can actually can turn on and go onto the platform.
Okay, I see some wrinkle faces. Hold on. Yes.
So the shooter, the only problem that I have with it is the inaccuracy of both flywheels being on the side of the ball, because if one side is spinning faster than the other, it will curve in where the
Okay, so the goal is to use encoders, but the goal is to use encoders, but I think if we have the motor controllers, I think that we'll be okay, because there's certain things about there's certain aspects of the game that, all right, so here's the deal. We had a guy come out on Wednesday, talk to the kids. What he said was that during the first round of matches, you're going to want high cycle times and scoring in the low goal to get your ranking points up. The problem is when you get onto the finals, you're going to be going up against very good teams that have very accurate shooters and can score the high goal. In order to make yourself desirable, it's good to have that variability. So the point is that you focus on the low goal to get yourself to the finals. Then you want to have the option of shooting in the high goals if you need it. Yeah.
If I don't get a decent time away from the is there a way day? Okay.
Same day.
Same day.
Hey,
So what they did by trying to get rid of the heater, all I was asking was to have it rotated so that the wheels on the top of the pump can put on.
I'm not sure that it would fit under the profile.
That was the only.
Yeah, I'm not sure that it would fit in the profile with wheels on the top. We have seen videos of successful shooters with the wheels on the sides. You have to use encoders and have the robot monitor speed.
We need to wrap up.
Okay, so is everybody happy with that plan?
What are we going to call it?
Okay. Well, okay. We will worry about what we call it later. Let's get the kids in here and tell them our new requirements. It's okay, Rachel, I promise. It'll be okay. What did you say?
Listen.
All right, kids, come on, come on.
Make sure that they're combining. We don't know, but.
Yes.
Okay, guys, so if you don't mind, I'll go ahead and call them. So here's the deal. We really like the simplicity of the uniform unicorn. We like the practice strategy of the game. There were, we really like Trump's shooter, right? But we also really like Essex low profile and skill. So we started out with, we just talked one part of the robot, and basically, they said, let's separate the variable mark, it goes up and down, replace it with the percent. And then these two people were like, well, hey, we can just replace the shooter and catapult with the shooter potential. So we had these robots together, and this robot over here, and they still had more people. But they also were like, well, what if we swapped out the back arm mechanism for these arms that we go in and go under the protocol? So we would like to shooter from this robot, the arm from this robot, and the strategy of the body mechanism from this robot. And the simplicity, well, that's the simplicity of that. All right, we'd like to put all of that into one robot. We don't have it made yet. And I'd really like to let these people go home. Is everybody happy with that? All right. Thank you so much for coming out. February 23rd, we will host a spaghetti feed reveal night where you guys can come back and see this wonderful Claymore session box. Okay, work in progress. Right, guys, thank you so much for your support.
If you would stay confused, they should have said, Michael said they could do it this way.
Yeah.
Plain Michael.
Yeah, I'm not sure what the clearance is, but it's really good to work.
The kids all look so confused.